Hello everyone. I'm making this video regarding the ComSys Lab 3, and I'm making this video because of a lot of my class fellows requested that they need some help with the circuitry. So I'm gonna start off with the first circuit in the Lab 3, which is VCO. And even before I start that, I want to just go over with the very basic of a breadboard, just as a reminder, because we all made, make mistakes. I do a lot of times. Um, just as a reminder, all the dots in this line, they're all connected, and they are not connected this way. They're only connected vertically. And also, all these dots in this one line, they're all connected for this bar right here and this bar right here. So in the VCO circuit, the components that we need are the capacitors. We're gonna need 200 picofarad capacitors, and then inductors, 212 microhenry inductors, but we do not actually have 112 microhenry inductors. So what we're going to do is the one we have available in the lab are 56 microhenry inductors. So we're going to just add both of them in series to make 112 microhenry inductor. Next we're going to need two 330 ohm resistor and 150 ohm resistor. And then next we need varactors. Vectors and transistor are very same. They look very similar, except that vectors have two terminals and transistors have three terminals. Make sure not to confuse both of them. Um, just some important points that will help you a lot in connecting this circuit. The first point is that the vector. If you look at the vector, the flat side up where the writing is, this is how it looks like if you look into the vector. So in the circuit, you'll see very similar sign like this. So if you put flat side up where the writing is, this is how it is. The right side of the terminal is this curvy shape, and the left side is just a straight side. And with the transistor, we have JFETs. For JFETs, um, if you have a flat side up side with the writing, this is the flat side, and then you're gonna have drain, source, and gate. So this is gonna be drain, source, and gate. It is very important to write down those things if you forget them, because you're gonna really need to know that which terminal needs to be connected to what part. Um, Another thing that I want to mention is the color coding on resistor. I know there are a lot of resistors sitting on the bench at the lab, and they're always mixed up. And when they're mixed up, you're always gonna get like different values of different resistors. Just to make sure that you get the right value of the resistor, the one I'm holding right now is orange, and brown actually. That means that I have orange, and brown, 330 ohm. Similarly, for this lab, we actually need a 50 ohm resistor, but we do not have 50 ohm resistor. Using a 51 ohm is still fine. It's not gonna make a huge difference to your circuit. So for the code for the 51 ohm is gonna be green, brown, and black. So that's 51 ohm resistor. Putting this aside, just to show you again, this is the circuit I'm building, and this is the VCO. One of the reasons why our professor said that the VCO doesn't work is because a lot of people just misunderstand this and these transistors. um, these are pretty much the only parts which can make the circuit go wrong unless you're messing up the wiring or anything else. You can certainly make a VCO like this one, but I know these are the wires we have available in the lab. You can still use these wires, but just to make things simpler and show how I will be connecting everything, I decided to use these wires. These wires are exactly same as those, but they just look more cleaner. Um, So I'm gonna start off with it's always better to cut the circuit if you have a bigger circuit. It's always better to divide the circuit in parts. Like for example, you can literally divide this top part and then the bottom part. It makes a lot of things, connections a lot easier. Um, so coming back to the circuit, let me zoom this in so you guys can see better. Yeah, okay. So this is actually the top part. This part is this part right here, V3. One of the things before even I start telling you this wiring for this circuit, V3 always has to be bigger than V11 right here for your circuit to be able to work properly. Always remember that. Um, so this is our V3, starting point of V3, and then it is going to two inductors, 112 microhenry inductors you can see on both sides. So this is exactly what I have right here and right here. Two inductors in series to make 112 microhenry. So after these connect inductors, you will see the connection is going into the vector. This is where you have to go back to the diagram and see which terminal of the vector looks like this and connect accordingly. So we're gonna come here and inductor is connecting to the right terminal of the vector. So we're coming here, let me just make it closer. So this inductor is connecting with the right terminal of the vector. Similar, exactly same thing on the other side. You're literally copying the same thing on right and left. So in between these two vectors, you're gonna see in between these two vectors are connected and they're going into a 50 ohm resistor. So these two vectors are connected and they're going into a 50 ohm resistor. And this resistor is then going into V11. I did not put any wire over here yet um, because I wanted the circuit to look cleaner for description. So this will be your V11. This is the place where you will be giving the V11. I'm gonna just take this out so that you can see the other components better. Now we are done with the top part of the circuit. This top part is done. You can see this is the top part. It is just that simple. Now we're gonna start building the bottom part. We obviously need to connect the top and bottom part, but we will figure that out later. Let's start with the bottom. You see there are two resistors, 330 ohm resistors. They're both connected and grounded. So this is 330, 330. They're both connected and they're grounded. So I'm using this as a common ground because all this is connected. It reduces your number of wire significantly, and it makes your circuit a lot better and more efficient as well. I would always recommend you to use these plus and negative signs. That's why you have these wires on both sides, so you can use them for different voltages or same voltage or common ground. So I'm using this blue one right here for the common ground for the whole circuit. So whatever the voltage I will be giving here, with the red wire. I'm gonna connect the positive terminal here and the negative terminal of that voltage to this common ground, and then I'll be connecting this with the Keithley or whatever we're giving the voltage source from. Okay, coming back to the circuit. Um, so the way this circuit is, the resistor is gonna be connecting with the source of the transistor, and the middle part is the gate and the top is the drain. That does not say in the lab, but it certainly does in the theory, and I have tested with this configuration. It definitely works. So this is a transistor we have. Again, looking at the diagram, we have drain, source, and gate. So the top part right here is gonna be drain, source, and gate. So source is actually connecting with the resistor. As you can see here, source is connecting with the resistor on both sides. So that's what we're gonna do here. Is this source is connected through this wire. I apologize, I actually messed up myself. It's drain, source, and gate, right? So this is drain, source, and gate. So the middle one is actually the source. So this source is connected through this wire, and this is going into the resistor. Just like here, this source is going into the resistor on both sides. So this wire right here, let me do this so you can see better. So this wire from the middle of middle terminal of the transistor is going into the resistor. So you're literally like copying the same circuit on the right side and on the left side. Um, After that, the easier part is to connect the drain with one of the capacitors. We're using 100 picofarad in this case, so we're gonna be connecting drain with capacitor. So just connect the drain, which is the first terminal, with the capacitor. So this wire is taking the drain into this first capacitor, and do the same thing on the other side. Um, Drain is going into the capacitor. Now come back to the diagram. The other part of the capacitor is going into the gate of that transistor. So remember, the other part of the capacitor is going into the gate of the other transistor. So this other side of the capacitor is connected through this wire and going into the gate of this transistor. You do the same thing on the other side. This side of the capacitor is gonna be connecting with the gate of this capacitor, this transistor, sorry. Now we are done with this part of the circuit as well. Only thing we need to do is just connect this and this wire to connect the top and bottom. So we are doing this by using these two wires to connect both circuits. And that's pretty much it. Let me know if you guys have any questions. Thank you.